This is video number 3 for sections 7.1 and 7.2, working with standard form. So now that we've learned how standard form works, let's take a look at a real example. So here's an example of a quadratic function. You can see it's in that standard form, y equals ax squared plus bx plus c. Let's answer a bunch of questions about this particular function. The first one is easy. What kind of graph would we get if we were to draw this? Well, obviously a parabola. Direction refers to, would it be an upward opening parabola or a downward opening parabola? Remember, it's the A that tells you that information. Well, here's the A. It's that -2 right in the front. Since the A is negative, this particular parabola will open down. When I say shape, I'm talking about that wide, narrow stuff. Well, that was also communicated to us by the A, specifically the value portion of the A. So ignore the positive, negative, just focus on the value part, which would be the 2. If that 2 is bigger than 1, then that tells you this parabola will be on the narrow side. Okay, then we come to the vertex. Well, here's where we're going to have to do a little bit of work. I'm in standard form. I'm not in vertex form. I don't have the h and k, so I can't just read the vertex right off the equation. What do? Well, I need to use that formula that we just came up with, that one that was h equals -b over 2a. That is the way that you should always be finding the vertex when you are given an equation in that standard form. It's very simple to use. Just plug in the a and the b in the appropriate places. Use the slots idea. So let's see. The b in this one is a 6, and then the a is that -2 that we've already been talking about. Make sure you get all your signs correct. That gives me -6 divided by -4. You will be happy to hear that decimals are just fine here, so just grab your calculator, type that in, and you will get h equals 1.5. So that's the h part of the vertex. I'm not done though. I also need to figure out the k. Well, we said in the last video that the k is easy to find. Just realize that this 1.5, it's an x-coordinate. If you want to know the y that goes with it, just take it, go back up to the original equation, and fill in 1.5 everywhere you see x. That will tell you the k. In other words, the k is just the y value you get when you replace all those x's with 1.5. You can just type that all into your calculator, and what you should get is 0.5. Well, now I know the vertex. The vertex is the ordered pair 1.5, comma 0.5. Again, this process that I just used here is what you need to be doing every time you want to find the vertex in standard form. Okay, let's keep going. We want now to draw a graph of this particular function by hand. Well, we talked about this when we were studying vertex form. If I asked you to graph one of these parabolas by hand, I expect to see a table with 3 entries. The vertex should be the middle entry, so I'll fill that in the middle. And then you should have 1 point on either side. Now, when we were doing this in vertex form, we would maybe go back 1 and forward 1, or back 2 and forward 2, or something like that. This is much easier in standard form. I don't know if you've realized it, but I already know one other point on this parabola without doing any work. Because remember, this c at the end, we learned that's the y-intercept. I know already the point 0, -4 is on this thing without doing any other work. Notice that I went 1.5 backwards in the x direction. Well, to find the symmetrical point, if I just go 1.5 forwards, 1.5 plus 1.5 is 3, then I know that the y value will also be -4. So there's my 3 points without even doing any additional work. Let's go ahead and mark the points on the graphing grid. So 0, -4, 1.5 comma 0.5 would be right about there. 3 and negative 4, there's the symmetry. And then connect the dots and I've got my parabola. Notice it opens down, just like we said. It's kind of on the narrow side. We've got the vertex marked, our 2 points. Everything is coming together. Well, let's answer a few more questions about this quadratic function. The next thing we're being asked is the domain. Domain, remember, just means all of the possible x values that could ever show up on this function. Well, this parabola just keeps getting wider and wider as it gets lower, which means eventually every single x imaginable is going to show up on this thing. So the domain is just all real numbers. In fact, the domain will always be all real numbers for any quadratic function. How about the range? That's a list of all the y values. Is that going to be all real numbers? Well, definitely not. I mean, you can see from our picture here, there's a whole ton of y values up here that are never on this parabola. In fact, there is a highest y value. It occurs right at the vertex. It's that 0.5 number that we found earlier. 0.5 is the highest. Every y below that does eventually get used. That means our range is all y numbers that are less than or equal to 0.5. The range will always have something to do with the k part of the vertex. Next question. How many x-intercepts does this particular parabola have? Well, you can see there are 2 places where it crosses the x-axis. So we'll say there are 2. And then the next part says, let's go ahead and find them. Now, just from the picture, I mean, it kind of looks like maybe it crosses here at 1 and 2, but that could just be a coincidence of how I drew it. I mean, maybe it's more like 0.9 or 1.1 or something like that. I want to know for sure what the x-intercepts are. Well, how do we find x-intercepts? We've done it the same way from the beginning of the semester. We set the y equal to 0 and we solve for x. So take that original function from the beginning of the problem and set y to 0. So I've taken my original quadratic function, I've replaced the y with a 0. Now I need to solve for x. What kind of equation is this? It's a quadratic equation. We only have one method so far for solving these, and that is the factoring method. Step 1 is get a 0 on one side. I do have that already, although I notice that the lead coefficient over here is negative, and I never really like that, so I think what I'm going to do to make my life a little easier is take all of these terms and move them to the other side, which really will just change all of their signs. So that gives me 2x squared minus 6x plus 4 equals 0. Then I start factoring. I do have a GCF, namely of 2, so let's pull that out. And then the rest of it is a trinomial. It looks like somebody's FOIL problem. You could use the Xbox method, but I think that's really overkill when the numbers are extremely simple like this. The only way you're going to get an x squared is x times x. The only way you can make a 2 is 2 times 1. I just need to make sure the middle part works out. Let's see, if it's a positive 2 and a negative in the middle, the only way that would work is a couple of negatives. And I think that's it. Negative 2x minus 1x makes negative 3x. There's my positive 2. Great, we're all set. Then I use my 0 product principle. If you multiply a bunch of stuff together and the answer is 0, one of those pieces has to be 0. Well, I know it's not the 2, so that leaves one of these two to be equal to 0. I'll write that down, and then I'll solve each piece for x, and I'm done. I'm going to end up with x equals 2 and x equals 1. Remember what we were doing. We were trying to find the x-intercepts. We have just discovered that there are 2 of them, just as we saw from the picture, and they occur at x equals 2 and x equals 1. If I wanted to state my answer as ordered pairs, one of them is 2, 0, and the other one is 1, 0. And that means that my picture was actually pretty accurate. If I go back up and look at that parabola, sure enough, it really did go through this 1, 0 spot and this 2, 0 spot. In the next lesson, we'll talk about how to find x-intercepts if factoring doesn't work. In other words, if this is prime, what are we going to do? There is a way. We'll learn that next time. Okay, lastly for this problem, we're being asked to take that original quadratic function that was given to us in standard form and rewrite it in vertex form. Well, this turns out to be very, very easy as long as you understand what vertex form means. Let's jot down the form. All I need to be able to do is fill in A, H, and K. Well, I have all that information. A is the same A from standard form, which was -2. I don't have to put any thought into that. H is the x coordinate of the vertex. Well, we already figured out that that was 1.5. And then K is the y coordinate of the vertex. We already figured out that that was 0.5. So as long as you've figured out the vertex, you can easily change from standard form to vertex form. What if you wanted to put it back the other way? Well, remember, that's a little bit more involved. We've practiced that before. That's where you have to FOIL out this piece and then distribute the -2 and then add in the 0.5. You might want to try that on this one just for the practice. Remember, when you're doing the homework, have these notes out in front of you so you can make sure that you are solving the problems using these methods that I have shown you.